You're here, and it means you care about cybersecurity. So guess what? You're at the right place. I'm excited to introduce SIBE. It's a global initiative by Cloud Security Alliance Bangalore. So if you haven't heard about SIBE, it focuses on cybersecurity knowledge, mentorship, and collaboration. So our goal is to empower professionals, students, and cybersecurity leaders. We provide expert insights, hands-on training, and strong learning community. So CSA Bangalore has been a leader in security awareness, research, and best practices, not just in India, but worldwide. So with SIBE, we are reaching even further. We are connecting people, starting discussions, and shaping the future of cybersecurity. So now let's talk about learning. We are excited to launch a new webinar series of CISSP Deep Dive. Whether you are preparing for CISSP or just starting for the CISSP, this series is for you. So we will simplify complex topics, discuss real-world cases, and invite experts to share insights. But that's not all SIBE is about. It's much beyond, wherein it's a hub of cybersecurity growth. We offer mentorship program, hands-on training, and expert discussions on cloud security, AI threats, zero trust, and more. So if you're ready to level up your cybersecurity game, stay connected, join the conversations, and be a part of Side Movement. Follow us for more updates and sign up for our webinars and build a stronger cybersecurity community together. So with that note, I will hand over the session to Shravan, who will be taking up on the domain 4, which is on the communications and network security. Hi, Shravan, welcome to the board, and I wish you good luck.
Hey, thanks everyone for joining in and making the time on Saturday. So I will briefly introduce myself. My name is Shravan Kumar. I work with Deutsche Börse. I'm based out of Germany actually, but I moved in here about 1.5 years ago. I used to work in Bangalore, and I have taken part in CSA Bangalore's chapter meets and the annual conferences. And uh, uh, huge shout out to Satya ma'am, Pooja ma'am, and the other coordinators for running the one of the best chapters, cyber security chapters, I must say. Congratulations on that, and also thank you for giving me this opportunity to share my knowledge with you guys. And hopefully I also get to learn. I may not be the expert in communications and network security, because I work in IT audit. So I use these stuff and these concepts, but if you ask about configuring and engineering solutions, I might not be the guy. So I will share my knowledge, and if I do not have the answers to questions, maybe I will try to find it up and come back to you at that time. So please feel free to stop me and raise any queries that you may have. That is fine. Uh, and I will now share my screen so that I can share this slide deck with you. Um,
So while Shravan is coming up, Shravan, I just want to especially thank you. I know it's early in the morning in Germany and also on a weekend. For that, thank you. And also, just to add on one more comment, Sima have done very well introduced to SIBE. Just I want to also speak about one comment, which is all the speakers are sharing their knowledge and then giving back to community. Even these courses, the costs are made it affordable and economical just to run the operational cost of running the tools and other mechanics involved for running this program. Just be mindful of that, and then make use of the materials what we are sharing, and also the platform, the SIBE LMS platform you are part of, to run mock drills and mock tests, which are also a part of it. You will get to access it after this session. You can actually do your tests. most important is practicing. Yeah, with that, I'm just giving back to you, Shravan. I think your session is ready right now. All the best.
Thanks. Okay, so uh, first check in. How's everybody feeling today? Good. How is everybody's confidence level? Just you can. I'm not sure if people have the access to chat. So if you are to appear for exam today, are you ready to take this in the examinations? Because um, not sure if the aspirants have the idea of the CISSP exam, and not sure if something has changed. I got CISSP certified in 2019, and so how much weightage is this chapter? 16 or 13%? Can somebody ping a number? How much weightage is this? So if we were to appear for this examination today, will we be able to do justice to this topic? Yes, no, maybe. Okay, 13%. Okay, okay, okay. So okay, so why I just wanted to give some context as to why communication and networking came about in the first place. The thing was, in earlier days, it used to be the case that big mainframe kind of computers were used, which really took up a lot of space. If you compare that, you might have more computing power in your phone than all the computers in the world put together. So 50 years ago, but what people thought was, and you had multiple sessions from the computers. So you had a big computer and you had many terminals called teletype terminals. Operators and processors used to work on these terminals, and they used to send their requests, and they will process that information and be done with it. But the question came like, what if I need to connect these two computers together to exchange information? Will it be possible, and will it be reliable? And this also handed up the defense agency of US also had a very interesting part to play in it. They were more interested, like, we should be able to exchange information in case of any catastrophe or any situation. There is no place is accessible, then no phone lines in a particular place. Even then our message should get through. That was the kind of thinking which people had. So they designed some things and built on it, and that eventually became what we call the internet today. So uh, 1 minute. Yeah. So this was what became eventually the internet as we know it today. So how many of you have written posts or are young enough to write letters, or remembered having written letters? Shout outs, yes, no, only WhatsApps. Okay, so have you seen how the letter eventually makes its journey? Have you wondered about it? So the thing was, when we write and when we receive a response to that letter, it seems as if we are writing and we are just putting it in a post box, and all the things behind it, we are opaque to it. It is not visible to us. And eventually we get a response back saying that for our letter, and the conversation just continues in back in the days when that is how it used to continue, right? So similar is the case with designing this system, where they built a top of imagine if you are writing a secret letter. now, or may not be secret. So if you are to write now a secret letter, then two parties must agree on how exactly we should communicate, what is the language, how to ensure that it really stays secret, uh, how does the sender know that the receiver has received the message, how does the receiver know that the sender has received the message, how does he interpret the message, and so on. So, and how does it really reaches the receiver? So these are the things which are uh, being which people modeled on and designed eventually what was known as the OSI layer, or this was a visualization of all the systems in place, how a message should get to from a sender to a receiver. So so the language, in that analogy, so forgot one tip. So this chapter is, I like to call it king of analogies, because it's by nature a very dry chapter. There are parts of this topic which has a lot of statistical information, a lot of specifications, etc., which you have to remember. They won't test the statistics or your remembering capability, but what will be tested is your ability to apply it in a concept or in a situation and do it subsequently. So that is what is tested. And so if you remember, my suggestion to you while reading is, if you are preparing for this chapter, try and remember it as analogies. In that way you will be better able to connect. And also one more tip is that you should try and not to choose options. You should rather try and eliminate the options. So there will be 4 options, I think, per question. And when you try and eliminate and have a justification for your elimination, that is a more sure shot way of getting your answer right. So that being said, so now, the coming back to our analogy, the letter analogy that I told. So when you send, first is the language. When two parties are corresponding, they should be able to understand each other. Only then it makes sense to write to each other. So the languages of the internet are protocols. When I speak to you now, there is a protocol which is running in the backend, and it is communicating with the other components or pieces in the network through protocols. That is how this is being enabled. And every protocol has something called a PDU, or a protocol data unit. It is its own overhead and its own proprietary information that it adds to our information that we originally sent it. It is like, in the case of the letter, think of it like the postal stamps and the postal marks and the acknowledgement which each and every person gives. So when you send out this envelope, the on the sender side there will be a postal mark that this was posted from this post office, and on the receiver's post office there will also be this postal mark. So uh, if we compare that, then that is an analogy. I think we can it is useful to compare it in that sense. I will dwell on this this will be a running theme, of course, in this presentation. But if you think like this, it is a useful hack and a useful concept in that way. um, how many of you have I'm not sure how many of you have seen this video. I will try and play it. uh, uh, I think it is now a cliche and a rite of passage to play this video as an introduction to do anything with networking. Have you heard about Warriors of the Internet? Yes, no, maybe. Should I play it? Can we play it?
Yes.
Okay. Uh, Sorry, is my video screen being visible? I don't think so. It is. No.
No, Shravan.
Oh,
Not.
okay, okay. I thought I am enjoying the video. I just left you guys 1 second. Okay. So then I need to fix something in my presentation. Just a second. Okay. Now is it visible? I think
Yeah,
yes.
it's showing yes. It's appearing.
Okay.
There's no volume, Shravan.
Oh, volume is not enabled. Okay, maybe. Oh, okay. Okay, then maybe it makes sense to watch it in your leisure. I will switch back to our original presentation. My mouse is behaving strangely. I don't know why. 1 second. So I will go back to my presentation and okay, is it loading?
Yes, it's showing.
Okay, okay then. You can watch this at your leisure. It will talk about a journey of an IP packet and through the various levels of layers which we are about to discuss now. So I will go on to the next slide, which is talking about the OSI model. OSI model refers to a visualization of the various layers through which our information is processed going down and in the sender level, and at the receiver it is traversing all these way up and going up, and the receiver is able to receive this information. The thing about this is, and you have two types of representations, one is OSI and one is TCP. So the TCP has only 4 layers, but OSI is much more detailed. It has 7 layers. It is popularly remembered by the mnemonic. Are you aware? Um, go for 1 minute. Yeah, just a second. I will share again. My screen is showing now correctly. Yeah. Okay. Okay. So
Yes, it's showing.
to
Just do the presentation mode, no? You're showing all
okay.
the slides. Yeah.
Okay. Yeah. Okay.
Shravan, you're supposed to press F5. It will go on full screen mode. That's
Yeah.
what.
Yeah. I'm there. Now is it better?
No, it's not showing.
Your screen sharing stopped.
Oh,
Screen share is stopped.
that is my screen share. Okay. F5 in the PPT and present. Okay. Now is it better?
It's loading, Shravan. But it's not in presentation mode. Just in the bottom right corner where you have zoom options, right? The
Hmm.
presentation mode is just click there. Down, right hand corner.
So
In the
before,
Google Meet.
no,
No,
in,
in the slides itself.
yeah, before the minus sign on the Zoom, just there is a icon. Just click that icon on the left
Right
hand
hand side, down. Right hand side of your PC.
bottom
But
right.
in my bottom right.
Bottom right, there is a Zoom presentation Zoom option, right? Plus minus. Just next to
Yes.
the minus sign, there is one
Ah.
icon. Just click that icon.
Okay. Okay. 1 second. I will then.
Stay on the
Yeah.
screen. Just click that icon.
Okay. 1 second. Sorry.
Share your presentation. Stay on that screen. Just click that icon. It will automatically move to presentation.
1 minute. Okay.
Your screen is not showing.
Yeah. I stopped the presentation.
Okay.
Now, what I will do is I will present again and do what the step what you have said. Okay. Okay. Better now. I think. Yeah. But oh. Thank you. Okay. Not the slide I intended to present. Yeah. Okay. Good. Okay. So okay, but coming back to topic now, the TCP/IP model has only 4 layers. This has 7 layers, and the popular mnemonic, right? There is a mnemonic called "Please do not touch Steve's pet alligator." Have you heard of it before? Are you aware of any other mnemonics? Please ping them in the chat. So it is used as a mnemonic to uh, remember these 7 layers of the OSI model. So physical, data link, network, transport, session, presentation, and application layers are there for in this particular model. So what is happening actually in the backend? Still not in presenting mode. Why?
Or just do Control P and C.
I am seeing it. I am using a secondary screen actually. So I should
I
not
don't
use it.
know.
I think.
Everything is showing, and it is very small fonts. Whatever.
Okay. 1 second. Sorry.
You can just try pressing F5.
Maybe or
Yes.
zoom it, no, sir, Shravan. Just zoom it. Just use the zoom options, no. Just see
Okay.
if
Okay.
that help.
No, I think the presentation mode will still work. Either they have to press F5 or something. It will
Yes.
just go
I,
to
I
full
this
screen.
is presentation mode. No, I have to just press this.
Yeah, you clicked it, but I don't know why
Uh,
it is. Maybe little zoom out, little zoom out.
Little zoom out. Okay.
Reduce the to reduce the space. No, it's
Mm,
half of the screen is not showing. Zoom. Yeah, yeah. Minus. Yeah, little more.
okay.
I think this is better.
Now better.
Yeah, as of now, yeah.
Okay. Okay. So okay, where were we? Okay, so the coming to the next point, the speciality of this is that you have these layers were built on the concept that the sender and the receiver side, on both sides, it feels as if uh, only those two layers are communicating. For example, application layer of sender is communicating with application layer of receiver. Yeah, it feels like that. The example for this is I requested a site on my browser. So the application layer on the sender side is the browser, and on the receiver side it is the Google server. So it feels as if they both are communicating, but beneath, under the hood, there are so many parts. So the application layer actually now gives it to the presentation layer via API. So each and every layer is connected via API. So when the application layer gets the data as user input or a request, then it passes it to the presentation layer. Now, after this, the presentation layer will do its work. So the job of the presentation layer is to encode or transform the data in any way or encrypt. That's why this layer is very important for encryption. Here, many the encryption will happen, and here the method of encryption, how the key exchange, all of this is taken care in that layer. The session layer is responsible for allocating resources between the two applications that are communicating. For example, we can take this session itself, right? So so many people have joined for this session using this link at this time. But if we consider it, the session is not available at a later point in time. So if we join tomorrow using the same link, it is not available. Similarly, in the session layer, resources, be it computing or bandwidth or network, is reserved for a particular two particular applications on both sides to communicate. Applications could be many type. It need not be only necessarily web page, right? It can be video, it can be files, it can be anything. So this session layer is responsible for getting this data in an orderly fashion and in a manner which is most optimal and most preferred. Don't want the climax of a movie, if you are watching, to come after, immediately after the introduction scene. So that is an example how we can understand the session layer. Transport layer is responsible for delivery of a packet or a message to the sender. It will ensure that it will or yeah, not in all cases, it will take the effort to somehow uh, make this application or this message reach the sender and the receiver on both sides. I will talk about transport layer in much detail because each of these layers has its own set of protocols. You can study more about it in the readers or in the official study guides. But the point is, the transport layer has two main protocols, that are TCP and UDP. We will speak more about the protocols, like I said, in the dedicated section called protocols slide. um Moving on to network is mainly the language of communication of how the packet should flow. For example, the like with all definitions, we like to say that the internet is a network of network, right? So what does it really mean? There are many small networks connecting to a large network, and that is in turn connecting to a large network. So when you are sending a packet, the network protocol is making an effort to deliver the protocol to the destination by whatever means. If it does not know how to go, it will ask. It is similar to our real life, right? So if we don't know to go to a particular address, we will somehow try to reach. We will ask a few people. We will consult Google Maps. If a route is not accessible, then we will take an alternative route. Similar is the job of the network. So the network will do this for us. So the main protocol of the network layer today is the IP. Two versions are available for IPv4 and v6. We will talk about it. um, Data link layer is actually responsible for, now this is all fine, but the information has to travel on communication medium. It can be wires, it can be wireless, it can be phone cables, it can be broadband, it can be any kind of, it can be even satellite. So this data link layer is responsible for doing this communication, placing these bits, because at the end of the day, computers understand only bits and bytes. So these bits have to be placed on the wire for their transport, and physical layer is actually responsible for carrying these bits to the destination. So data link layer, I forgot to mention, is divided now into two sub layers, if you will. Those are called logical link control and media access control. So there is if there is a communication channel and there is it is shared between multiple people, how exactly you should share that channel, that is regulated by media. It is like a traffic policeman regulating the vehicles so that all the people are not at the road at the same time. And a logical link control, the logical link control is the layer where your uh, uh, the information is got from the above layers and placed into the media access control layer. So it is packaging that bit of information in a manner which can be carried by the communication medium, let's say. So moving on to the next slide, this is called like we talked about protocols and PDUs. PDUs are the data units. So once the information is going beneath every layer, it is adding its own overhead. People like to call it as overhead. So that black part that you see, that is the extra data that is being appended to the data. So because the like I said, the presentation layer of sender is communicate, it seems as if communicating with presentation layer of receiver. So uh, it it should, the presentation layer of the receiver should understand what the presentation layer of the sender has sent. So it only deals with its overhead and no other overhead. So once it goes to a below layer, it is added, so another overhead is added. So likewise it is descending down all the layers, and it is becoming this sort of big uh, data packet, if you will. So and the reverse happens when you go up the layers at the receiver side. So this data is received, the for last two overheads are removed, then you process that, then it is removed, and so on. So it is like putting your letter in an envelope, then in another envelope, then in another envelope. So it is encapsulate, you can understand encapsulation like that. So this is another slide I thought will be useful. So this is your application layer, and this seems as if um, the sender and receiver layers, the counterparts are communicating with each other, and they are unaware almost about the presence of the below layers or above layers, if you will. And it also says the function of each and every layer. So like I said, presentation for encryption, compression and formatting, session for session maintenance, transport for end-to-end connection, datagram for your the transportations between the networks, frames for placing the bits on the media, and uh, physical layer is responsible for actual transmission of the bits. So that is one of the slides I thought will be useful. So just a second. Oh, sorry. Yeah. So let's just zoom in on the network layer. So I talked about the transportation layer. I talked about there are two variants or two different transportation layer protocols, mainly the UDP and the TCP. So UDP is a unified datagram protocol, and TCP is the transmission control protocol. So this is uh, the TCP is responsible for the reliable connection. So, for example, in the postal analogy, if we consider that we are sending a very important package, we need to get an acknowledgement that this was received. On the receiver side, he signed something, and it is posted back and maintained in the service provider's records, so that they have an acknowledgement that this particular um, receiver has indeed received it. So similarly, that is the case with TCP. They ensure that this uh, uh, transmission or this communication was received by the counterpart, and they send it to the sender and the receiver on both sides. So this is also called SYN-SYNAC ACK. If you I will talk about it again, but just to give you an idea. But this is not the most ideal in all the cases. There might be situations where you need fast communication. For example, if I don't know, if I'm really running late for a train, and I'm trying to determine which platform my train is arriving on, then I need what my need is not acknowledgement and I have understood it. They should really respond fast and tell me the platform number, so that I rush and just get this train. So these are some of the popular again TCP and UDP protocols. So this is the uh, many types of protocols that we have. So UDP protocols, we have DNS, FTP, echo, SNMP, etc., which need this fast communication. You need the you don't need the acknowledgement that the sender has actually the receiver has actually received the data. But in some cases, we need this confirmation, like HTTP or DNS or SMTP. We
Shravan,
need, yeah.
your slide is still 4 only for us. Yeah, it has not moved beyond that.
Exactly. Yeah, that's what I mean.
Oh,
Yeah, we are still. I can still able to see slide 4 because I thought you are explaining the
Maybe
relay combination, but
just put
we are.
down or something. Yeah, I think it's.
okay. I think I will be better in this mode.
No, you're still
Because
not
if I,
sitting in presentation mode.
yeah, okay.
I think, don't know why it is not working for you. That's
Yeah,
okay.
because once I go to presentation mode, that big screen props up, and I'm doing this. I'm controlling the slides. So But
Can,
if I
can
want,
someone else take control of your slides? I don't know. Someone else can present. Or
okay, I'm okay with that.
do you have the slides with you?
Yeah, sure. Then just give me a minute. I also need to connect my charger. Just give me a second.
Seema, do you have the
Otherwise, my
slides?
yes, I have my slides.
No, no, I'm asking Seema if she can present.
No,
I will share.
we'll share
One.
it on the group.
Okay. Please present, Seema, if that's okay with you.
Yeah, I'll do.
Okay, just give me 2 minutes. I will connect my charger also.
No problem.
Just give me. Yeah.
While Shravan gets the charger, so anybody have any interesting things to share about the TCP layer? So far we discussed. You can text in there. There are 7 layers. There are some traffic policies and something else we discussed. And just give maybe 2 or 3 bits what you learned so far in the text. Quick guys, we require some engagement to happen. No, you didn't learn anything about TCP IP layers? No? I'm not seeing any text coming in. You want me to ask some trick question? I can do that also. How many layers are there in TCP IP? Maybe let me ask that. You can put the number there. That's easy, right?
OSI is 7.
Yeah? 7.
OSI
What are they? Somebody given 5.
Okay, 3.
4.
3 layers. Okay.
Yeah.
4 layers. Okay.
Yeah, 4
4
layers.
What are they? Can you type in there?
Yeah. Application layer.
What those layers are? Can you type? What are those layers? Okay. Kannan given all 4 layers or 1 layer. I don't know. Go on. Okay.
So there are 4 layers. Application layer, transport layer, internet layer, and network access layer.
Okay. Who given all the answers correctly?
Lokesh.
Lokesh. Lokesh, excellent.
Into the application layer, we can say like our browser and all, which used to communicate with each other. And that is make a inbuilt. It has the presentation and the session layer, we can say, because after the OSI, it's been converted to TCP/IP and all those 3 packages inside of the application now. And then the transport layer, usually datagram has to be traveled where we can see the ports protocols. It will come inside of that. And network layer, it's usually for the packets where the packet has been traveled across the network to reach the IP to IP communication. And network interface layer, we can say it's the combination of the physical layer and the data link layer where we have the MAC address and all, MAC and LLC with the bits and bytes which is traveling across the wire. So this kind of 4 explanation I can do.
Excellent. Thank you.
Thank you.
Anything else interesting you learned about any of the layer? Something new you learned today?
Not yet. We are just initially it's going on the data. uninstall communication. So now I'm
Okay.
just learning like application to applications communicating each other, and all the layers usually as a virtual way. It's communicating each other, but physical way it is going across the layers, and over the wire it is sending over the bits and bytes.
Yep.
Okay, and then sending receiving to the other end, to the destination.
Okay. I'm happy that they are not following Indian traffic rules. You can
True.
go on any lane, right?
Mm.
Then it will
Yes.
be so much of mess. Okay.
Network layer ensures that it reaches the destination with
Mm.
whatever IP that it has been given as a label.
Okay.
No, not network transport.
Okay.
So that's what they say about IP protocol. It is a best effort delivery protocol. Do you know? Means. Do you know what that means? The best effort means I will take best effort to try and deliver it. But if it does not go, it does not go. That's it. So
Okay.
transport layer takes the effort, not network.
Yeah, guys, this is very tricky questions. These are the type of questions comes in CISSP. So, who takes care of the best effort basis? Who takes care of guaranteed delivery of the data? Who takes care of the arrangement of the data? So, I think you need to have the principles right. They look very
Yeah.
simple, but confusing when the question asked in the exam. Yeah.
Yeah,
Um,
because see again from examination point of view, the thing I encountered was make mind maps and try and apply it in scenarios. Only then it will be. Otherwise, everything is ending with protocol. Everything has associated statistical information that you have to remember. So the only thing is that you need to know why this is being done. For example, that network thing, the IP thing itself, right? So uh, if for example a particular path or no path to that destination is available, let's say, then what happens? It will try an alternative route. If that also fails, then what happens? So it will keep trying, and at some point it will say I cannot do it. But that is the best effort delivery. It will try to do it at any cost, but there is no acknowledgement or anything, because when two routers are communicating across the internet, let's say, and if they are acknowledging each other, then that is difficult. That will cause a reduction in the performance. No, makes sense. Is it logical? Yeah. So the coming back to our points about TCP and UDP. So when fast communication is needed, we need UDP, and when reliable communication with acknowledgement is needed, then we need TCP. Uh, we are also introduced to this other concept called ports. What are ports? So think of ports like counters in a bank. So a type of request will come to that particular counter only. If you go to loan section and try to open an account, it might not happen. If you go to account opening section and try to deposit money, it will not happen. So there are it is a logical path for your information to flow inside your computer. There are physical ports which is how you connect to the network. That is why it is called network interface card. So you are connecting to the network there via your network interface card. There are logical ports. So can anybody guess how many logical ports are there? Just ballpark, just some numbers. 100, 200, 300. Do you know why this number is existing, Swapnil? We will talk about it, because this number is nothing but 2 raised to 32. 65535 is nothing but 2 raised to 32. So inside the IP packet, there is one portion reserved for 32 bits, which is the reserved area for logical ports. Among these, the uh, 0 to 1024 are the well-known ports. That means they are standardly used for protocols. For example, if you want to communicate with a web server, then its port 80 has to be opened. And similarly, if you want to communicate through SMTP, then port 25 has to be open. If you want to connect to a server on Telnet, then you have to connect using port 23, and for SSH it is 22. So these are the logical ports and the for on a system which enable you to connect to a service. That is why the word server is also there, because it is making a service accessible via a port. That which makes a service accessible via a port is called a server. So these are if you think about it like this, then it is easy. So can we move to it?
So Shravan, will the question be like which port number and all in the exam?
These are not testable. Yeah, good point. Thanks for bringing it up. So you need not memorize all the port numbers, but uh, it is useful if you know the well-known ports, at least the most famous ones, like 4 or 5. If you can remember, that's good. But port numbers are not generally testable.
Okay. Okay. Thanks.
So the IP, yeah, 216. Okay, my bad with mathematic. Yeah, so 65535 is 2 raised to 16. You're right. Okay, so IPv4 address space is 2 raised to 32. Yeah, the entire thing itself. Yeah, okay. uh, so IPv4 address, we have a set of 32 bits which are representing IP addressing. So you have 32 a logical address for a system on a network. So there are two kinds of addresses for a system. There is a physical address, which is the physical address of a MAC card. It is provided by the manufacturer of the MAC card, of your network interface card. But the logical address is something you can determine, or your network administrator can determine and assign it to a computer. How this is done, I will talk about it also. But let's assume that for a moment you have an address, right? You should have a, so coming back to the letter, you need an address for yourself, so that the sender can the receiver can write back to you. Also, you need an address of the receiver also. You should know the receiver address also. Only then your letter will find its way to the destination. So if that is the case, then IPv4 is having 2 raised to 32 bits of address space. uh, each of them is of course unique, but uh, they thought this was sufficient initially. But more and more and more systems are getting connected to the internet each day, and not only systems, also devices. So if we were to assign a unique IP address for each and every device, then we are soon running out of IP addresses. For example, if we take, we all started our cell phones with the series 9. The 9 series ran out, then 8 came, 8 ran out, then 7, 6. I don't know what series is currently ongoing in India at the moment, but the point is, we are fast running out of IP addresses. So to solve that problem, we adopted two approaches. One is called natting. That is, we will reserve or some IP addresses to use as public. To use as private. They are not addressable. It is like your phone extension number. So my first extension number used to be a number called 23208. But I am gladly discussing this on a public forum, because I know that it has no meaning in the public world. If I dial 23208 from my cell phone, you will not get anywhere. So it has meaning inside the premises, but it does not have meaning outside the premises. So private IP addresses are like that. There are many areas of private IP addresses in the 10 series, in the 172 series. So these are addressing mechanisms. You may not have to deal with IP addressing and subnetting as a part of it, but why this is existing is something you need to understand. The concept is that this in the 192 168 series, there are some reservations made and earmarked so that these are used only privately. Then in the public address sphere, everything is of course unique, uh, and that is one approach. So, and when you want to communicate inside your network, you use the private addresses. When you want to communicate outside, you use the public addresses. Then that is fine to a level, but even then we are running out of public addresses. So people were wondering what to do, and they came up with IPv6. That means 128 bits of address space. That means 2 raised to 128 unique addresses. You do not have a concept of natting or this address translation we will talk about in the protocol section, but you don't you can use the addresses as they are. The problem with this approach is that all of them are not uniformly saying, waking up one day and saying that we are now going to use IPv6. That is not happening. So some parts of the world, some parts of the network are using IPv4, some parts are using IPv6. If you're not using, you should disable it. It might be a question in the exam, so watch out for that. So if you enable an IPv6 system and you don't have knowledge about it, then somebody can reach your system using that address, right? So that is something you need to take care of. And these two protocols don't natively talk to each other. You cannot ping an IPv4 address from an IPv6 address, and vice versa. So you have many translation or tunneling protocols. So you either put this IPv4 packet inside the IPv6 packet and send it and try to do it, but natively it is not possible. So there is a protocol called ISATAP, which does this translation and tunneling for you. There is something called as also 624. These are some things which is mentioned in the reader in great detail, but all these might not be testable. Only thing that is testable is that why we are using IPv6, and is it natting required or not. Then those kinds of concepts might be testable. So that is another part. We can move to the next slide. So IPv IPv4 packet, how does it look like? So this is the structure of an IPv4 packet. So this has total byte size of the 65515. That is the 2 raised to 32 bytes of address space. But the most important section for us are actually the version and the header, and some other protocols like TTL and protocol fields are also used to indicate what kind of packet is coming. For example, the header is like the table of contents of a book. So you know what to expect and what to find where. So this header is representing this structure. So this uh, header length and header will say what information is following after this. So then of course the most important ones are the source address and the destination address. So source, and it has to be of course unique, and you can also do various kinds of attacks with this, because if I forge my source as something else, and I route it to a destination, the destination will reply to the actual IP address who has it. It is like saying where it is like saying uh, Ram called you, but actually he hasn't called. I just said Ram called you, but so you will respond to him. So this is a kind of reflexive attack which is used often. You will see this in a number of scenarios. So this chapter is also very important for remembering attacks. What kind of attacks can be used at what layers? So each of the network layers that we discussed before are can be the target of an attack or a medium of an attack. For example, the network can be a medium of an attack. It can also be a target. So example is DDoS. When you have a DDoS, the network resources are not available and you are not able to communicate or send anything. But when the network itself is the target, that means somebody is trying to breach your network and trying to eavesdrop or sniff any packets that are flowing in the network. So we will talk about safeguards for all of this, but you can remember this for now. You can go to next slide. Yeah, so header. So this is what I was mentioning about header. The main thing about the IP header is the version and source and destination address and protocol. So this gives the receiver side what you should expect in this particular packet. When you when you write on top of this header, you know what kind of protocol is inside, what source address, what is the destination address. So when a receiver receives this source and destination address, it will capture it and simply reverse it. So the source, while replying back, it will put the source address in the destination and destination address in the source. So that is why this is important. um, and the that is why I've highlighted this on this slide. IPv6 has this 32 bit header length, and IPv6 has 64-bit header length. So this is something you can remember. It is not may or may not be testable. I am not remembering exactly at this point, but yeah, you can move on to next. Okay, so like I said, protocols are the languages of the layers and of the network components and the networks. Um, uh, how we are communicating to each and every each layer has its own protocols. So if we talk about layer 2, the important protocol that we should remember is called ARP, or address resolution protocol. It is also used in many attacks. Why do we need, first we should understand what this does. Why do we need this? So imagine uh, if a new computer is now joining my network, or there is a computer which is already existing and a message comes to that computer. Now, uh, like I said, the uh, unit of transmission of the layer 2 is the frame. Now, the switch, so we need to understand first the network devices, how they operate. I will cover it in the section, but imagine that the switch has a table which says that uh, this particular port, physical port on the switch, is connecting to this particular hardware address or MAC address or physical address, which I mentioned earlier. So you need to create or associate this physical address with a logical address. ARP does that function for you, because now you know that there is somebody called IP address, I mean MAC address AAAA or something, but you don't know who that uh, 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 who that IP address is actually having that physical address. So it always has asks the question who has. So it will come back with a response. So it is resolving that address. So for example, when I am sitting behind and a new computer is now added to my network and a message is now coming to that computer. Now that new computer has an IP address, but the switch does not know where to exactly put it, and uh, where which hardware address has this new IP address. So it will ask this question or broadcast this question across the network, who has this particular IP address. Now, the computer which has this particular IP address will respond back saying, hey, I have this particular IP address. This is my MAC address. Please update it in your table. So it will update it in its table. And now this association is now created. It is called a MAC table usually in switches. So it is an association between an IP and a MAC. So that's why it's called a MAC table. So when there is an entry incomplete, now this has to be this destination to this is mainly done. So for example, the layer 2 is communicating with frames, right? So you need a source frame, a source address, and a destination address there also. So when your destination address is not known, when the computer is joining newly, or when there is a replacement of the MAC card or something like that, these are the situations that will be asked. So they will ask, when a new computer is added in a network, what happens, or what is the process that goes on in the backend. I replaced my back card. Will ARP broadcast happen or not? Now, so when broadcasts are happening, usually the eavesdroppers are very happy because everybody is hearing everything. It is not something which I am discussing in private. So if somebody is listening on this network, then that hacker or that interceptor in between might try to play smart and say, I am that particular person. So the MAC table is wrongly updated and he gets the communication destined for somebody else. So this is a typical scenario. It is a common question in the CISSP. If there is any doubt about it, you can ask, of course, but you need to understand why this happens. So what is the need for ARP, the mechanism of functioning, which is the broadcast, and subsequent to the broadcast, eavesdropping happens, and because of that eavesdropping, a wrong entry is taking place in the MAC table, and then a wrong communication could happen, and there is breach of confidentiality. So confident, again, it will tie back all the concepts which I have learned in the previous chapters, like need to know confidentiality means it has uh, uh, the person authorized to receive it only has to receive it, and so on. So this is one of the aspect I thought which is useful to illustrate. We can move to the next slide. Yeah, yeah, Lokesh, tell me.
I have a question, Sean. My question is like, as you explained, but let's suppose as soon as a new machine comes, okay, and
Hmm?
he joins the ARP request and communicating with the other machine, and he started to do any black flooding and all. So what will happen in this situation for the switch or any other things into a network?
What happens to the switch?
Yeah, means if he's doing the ARP flooding as soon as because he joined, he could be the intruder who joined the network
Yes,
and by
yes,
the ARP, right? After that,
yeah,
he started to do some MAC flooding. So will switch have any impact or it will be run like a
yes,
normal way?
there will be wrong entries in the table.
Okay.
So switch has something called a MAC table. So uh, for that we need to understand how switches are working, because switches are devices which have a dedicated path to each and every device. So if there are, say, 8 ports in a switch, each port is connected to all the other 7 ports with a dedicated path. So what happens is, so now this at this port, at the end of the other port, one computer is sitting. So what this switch will do is it will maintain a table that my port number 1 is connected to MAC address AAAA. It will maintain this table. So when you do a MAC flooding, then what happens is, when there is this, when somebody replies with, I have this particular IP address, then it will create a wrong association in its table. That is what is MAC flooding. You cannot do it every time, but when it is successfully executed, it might lead to a data breach, because you have to keep sending the MAC flooding request, right?
Yes, yes. Unknown max kind of.
Yeah.
Okay. Okay. Got it.
Does this answer your question?
Yeah, like this one.
Yeah.
Shravan, in case of DHCP allocation of IP addresses, then this table will keep getting updated quite frequently.
No, this is the only for static case. For DHCP, there is another scenario, no?
Okay.
Yeah,
Okay.
the for but you are right. When there is dynamic allocation, your MAC table in the switches will constantly get updated. That is why you make something called as reservations in DHCP
Okay.
to avoid this. Have
Sorry,
you heard
one
of
more
reservation?
question. Okay. Sorry. Yeah, you can continue. Sorry.
Yeah. So if you have configured DHCP, you can reserve a IP address for a MAC address. So every time so today I am in the office, I go home. Tomorrow I come to the office. Every time it will be the dynamic. It is a dynamic allocation, right? So every time I might get a new address. So every time there is broadcast happening, first it is insecure. Second, network performance also will be poor, right? Because everybody is broadcasting. So the throughput of the network is not so much. The resources which should be used for communication are used in broadcasting messages, which is not optimal. So what they will do is, they will make a reservation in the DHCP server and say that this MAC address should always get this IP address, and this is valid for say 90 days. Then my IP address won't be changed constantly.
But that is also in an alternative form, not an optimized way, right? If you start allocating too many reservations, then if
Yes,
the devices are not coming back to the network, then they are still unutilized for a longer period of time.
correct. These are the decisions that the network has to be the network admin sit and plan. So they will see what address space is available, at least in the private, and see how we can make reservations which have people are not usually in the office, or they are one time joiners. We can leave them like that. All this people will plan. Yeah.
Okay.
Because IP addresses are at the end of the day limited, and there is only limited address space you can use. So you should conserve IP addresses. You should not waste them.
Yeah, please. Thanks.
Yeah.
Okay, Sean, I want to continue my question. My
Mm-hmm.
question from the exam point of view, do you have any questions like that? Like which kind of layer could be, which kind of attack it can be happen?
Yeah,
Um,
it is
okay,
testable. Yeah.
okay.
So
And
for example,
any,
ARP is happening in layer 2
yeah, correct. Okay,
because
and
you are
mhm.
dealing with switches and frames and those kind of topics. Yeah.
Okay, and any kind of questions like which kind of control we can apply in each of the layer?
Yes, of course. How can this be
Okay,
prevented? That is the whole point, right?
exactly.
Yeah.
Okay,
So
sure.
yes, MAC flooding happened. What can we do to prevent it? There
Exactly.
are, yeah. So you should authenticate before actually sending. You should authenticate before putting the MAC table entry. MACsec kind of solutions.
Okay, thank you.
Yeah. The see that is the whole purpose, right? So I can claim anything. I can claim that I am say Sachin Tendulkar, but how will people believe? People know him, he's celebrity, so people won't believe. But if I say that my name is so and so, my name is XYZ, Ram, Lakshman, whoever, then the next question is challenge that, no? And challenge that claim and see whether you are actually having proof to back it up. So that is authentication. That is the concept. So when somebody is trying to make an entry in any table, this will happen also at the higher layers. It can happen at routing layer also, right? It will say I need to go to this particular destination. The another router will say, hey, give me that packet. I know the way how to go to the destination. You just give it to me. It can happen. If you are having a confidential letter or very confidential thing that you want to give to the sender, but you are having to trust the postal network, maybe you should not even send it on that postal network. Then you should send it via encryption and so on. So that is why the encryption is sitting at the top. Now you see the concept of the layers, right? Why it is immediately below the presentation? Because when you put in encryption, if everything else fails, your encryption will save you. Otherwise nothing. Even if you have other protections, or if they fail, the encryption will save you. Because even if he access the data packet, he will get only uh, the gibberish, yeah, garbled values he will get. Nothing else he will get. Yeah. Any other points, questions? Okay, so we move to the next protocol. It is called DNS, or the domain name system. So they so like we know, the computers are understanding only zeros and ones. The point is that it is difficult for humans to remember zeros and ones. So they came up with this idea that we should somehow uh, put use these website names, or domain names as they are called, and have a translation into IP addresses, and the computers can use them. So you need a server which is having this association. So everything is association and a mapping. So many cases you can see this. So switch has a MAC table, DNS has something called the records. So it is also a mapping. Router has routing table entries, that is also a mapping. So it will associate A with B. That is something you see as a common theme in all the things. So um, coming back, we have the situation of this IP addresses, this domain addresses being associated with an IP address. Has anybody tried to ping Google www.google.com? Can you tell me what can be the result? What is most likely to be the result?
The series of pings of various IP addresses en route, multiple hops.
Yeah. So why? How did that happen? Because there was a DNS which resolved www.google.com for you. Exactly. So this resolver is doing this thing for you. So but the thing again with this is um, you have the domain name system with this IP addresses, but there can also be a situation. It is a single point of failure. This will also be something that will be tested. So if you need to access the internet, you have a DNS. Now you are having your DNS server goes down, then you are not having a proper access to your resources internally or externally. Then what should you do? You should maintain two DNS servers which are having copies of each other and updating and syncing each other on a regular basis. What if an attacker comes in between and says, please give me all your records, I am your secondary DNS server? That is a possible scenario. Now, again, you should authenticate him. So that is what DNS does for you. So DNSSEC is your protocol which authenticates this thing called zone transfers. Zones are nothing but areas in multiple domains are put in one zone. Multiple domains are put in one zone and called, and these are holding the actual record. So DNS is very valuable information for an attacker because it has the domain name and map to its IP address. So it is usually it is the first point where an attacker will try to access and see what information is available. Then he will try and uh, see what ports are open, what services are running. So you want to keep your internal IP addresses confidential. So internal and external IP addresses confidential. So that is something that the uh, DNS is used for. So used for name resolution. You should take care while transferring it to a secondary server, the using zone transfer or something. Then DNS can be used to also reflect attacks. Like I said in the previous scenario, please call this guy. That means the actual call, I am this guy, please call me. I am Ram, please call Ram. That means the call will actually go to Ram. That is also a scenario that is used. So I will query a DNS server using a spoofed IP and ask for all the records it has using recursively. So the actual receiver, my target, will receive all the big dump of DNS records. So it might cause a denial of service there. So it is called a reflexive attack or a reflective DNS attack. It is usually testable in the exam. So the how to avoid this, you usually do it. The DDoS attacks are usually prevented by uh, specific DDoS prevention network components and devices, but this can be a scenario that can be tested. Then you can also split your DNS, like you can have uh, an internal DNS for your internal resources and an external DNS for, because people also want to access your mail or web server or publicly accessible resources across the internet. Then you can have this particular external facing DNS to resolve external queries. So these are some of the points you must keep in mind while doing DNS. Then there is forward lookup, reverse lookup. I think that is not that much testable. Uh, you can do a domain to IP address mapping. You can also do an IP address to a domain mapping. That is called, have you heard or used a service called Whois? Yeah. So Whois will give, if you put a specific IP address, it will give you which domain or which organization is owning this particular IP address. So that is also possible. So any other queries you have for this particular topic? Can I move on to next, or we need a break? Yes, we can continue. Okay.
Hey,
So
hi, Satya here. I just want to check the time. How much to cover? What did we left out with?
yeah, we are having session till 1:30, ma'am.
Yeah. So we have one more section, right? Are we
Yeah,
going
yeah,
on good with the time?
yeah. We are on track with time.
Okay, excellent. I think the wireless section is something
Hmm.
I think can be done only between 12 to 10. That's 12 to 1. That's what I heard. I remember.
Okay.
Just want
12
to
to 1.
cross verify that.
Okay.
Yeah. Is she
Okay.
there?
Then
Let's check whether we have the speaker on the call. Just give me 1 minute. Usha, are you there on the call?
No, ma'am, she has not joined.
Can you call her maybe? She
Yes, ma'am.
said she's available only between this period.
Okay, ma'am.
Sorry for the disturbance. Just want
yeah.
to
Okay.
confirm how we are going. Yeah. Back to you, Shravan.
We may have to share the link with Usha if she's having a.
This link. Nainika,
I'll
can
just
you do that? Yeah. Yeah. Shravan, please continue your talk.
Yeah,
Um,
sure.
Maybe I
Just
think
just give me.
we need to manage the
I
time. I think she's outside and she has a
uh,
limited time. That's the only thing I want to tell.
so let me know if I need to skip to the other sections. Then I can continue with my parts later also.
No, that's okay. You continue, Shravan. As of now, I don't want to disturb the flow.
Okay.
As a organizer, me and Seema, just we are making sure all the
Okay.
sections are covered. We are making sure everything is
Sure. Sure.
good.
Sure.
But you are
Okay.
doing good
Okay.
job. Thank you, everybody.
Okay. Just a 1 minute pause for just I will have some water. Then we can continue.
Sure, sure. Go on, no problem. We'll manage. So, any guys, I think maybe this is the quiz time, right, Seema? You want to ask maybe one or two questions to the team randomly, or anybody have something to share about what we are discussing so far? Okay. So silent group. So let me ask a question, right? How is the session going so far? Is it going good? You're getting what you're looking for?
Yeah, looks like a lot of new topics which probably many of us are not fully thorough with.
Excellent, excellent. That is good to know. That's good to know. And these are you. This is useful for your preparation. Yes. Excellent, excellent. That's good to know. That's encouraging for us because this requires the team takes a lot of efforts to get the speakers on, get the content ready, and make this available. So just I want to be mindful of acknowledging their effort. I think Sima, you have done very good job in getting the great speakers like Shravan and others. Thank you. And I think now Shravan is back. I guess I see the cursor movement. Shravan, you're back? No, not it. Okay, so let me. Do you want a question? I can give one question related to any of the layer if you like, or you ask a question. We see what we can answer. Just I want to make sure you are going well.
Okay. So
Yeah, I'll going good then. It
so
seems,
back.
Ravan, you engage them very well. Now they don't want even to talk to me.
Oh, that's a surprise.
Good. It seems I saw a lot of thumbs ups going on. You're it's going well so far. So far, keep going, and I know it's a lot to take in a short time. Use the time
Sure.
effectively.
Sure. 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 Sure.
Up to you,
Okay.
Shravan.
So let's continue. So the other kind of protocol that we are about to see is called DHCP, or the Dynamic Host Configuration Protocol. That means there is so imagine a large network, and I have to go into each and every system and manually type in or configure the IP address on that particular system. uh, uh, what happens then? First, it takes a lot of time and effort, and second, it could also be error prone, because when you have the situation where two systems are assigned by mistake also the same IP address, it will cause an IP conflict on the network, right? Because then you when there is a broadcast, then there are two people replying with the same IP address. It is not possible. So then it will create that kind of scenario. So to avoid that, we have delegated this task of assigning IP address to a particular server. He's called the DHCP server. So then the DHCP server takes care of allocations. You can, like I said, also reserve IP addresses, and you have to just mention in which range you need to distribute IP addresses, and you should be good. um, this is possible also. Then it works in a 4-step process. One first step are also called as DORA. So discover, offer, request, and accept, acknowledge. So discover is that when a system first boots up, if it is set that have you seen this setting on your computer, obtain IP addresses automatically? Have you seen that setting? You can, yeah. So if that setting is set, then it will probe if there is a DHCP server sitting on the network. Then it will send a DHCP discover. So then an acknowledgement will come from the DHCP server that this, I am the DHCP server, and this is an IP address I can offer you. So then the client, which is in this case is the computer that has just booted up, which has it will confirm that okay, I am okay to accept this IP address, because it does not have an IP address of its own. So it will accept, and then the DHCP server will now acknowledge this fact that this is your IP address, and this is your time until it will be valid. So it will update this thing on the system. So it will look like this typically. The problem is that you can have a situation where the an attacker can come into the network and say, I am the DHCP server. That can happen, right? So there can be a system which is randomly assigning IP addresses on the network. How do you do it? Authentication, certificates, etc. So you prevent it like that. You can move to next slide. Yes. Yes, in most cases, yeah. You can also make it static, you can also make it dynamic. So this is one representation of the DORA process: discover, offer, request, and accept. So it first it probes and checks if there is a DHCP server available. Then if it is the DHCP server will say that this is an offer I can give for you. Then there will be a formal request, and then there will be a formal acknowledgement. So what happens if there is no, if it is not able to find a DHCP server? Do you know? Just find out. It is not testable, just for curiosity and trivia sake. Somebody knows?
Gateway.
No, I don't even have the IP address. No, what IP address will I get? That was the question.
APIPA.
Local
Junk
host.
IP. Junk IP address.
Yeah.
127.0.0.1.
You get a local host.
Yeah. You will get an APIPA address. You will get something in the 169 series. Correct. Okay, we'll move to the next. So this is SMTP, and SMTP is using the simple message mail transfer protocol, simple mail transfer protocol, using port number 25. Then there are mail servers which have these ports, of course, opened, and they are forwarding and relaying these messages. This can sometimes also be a vulnerability when an attacker is spoofing and trying to send mails from another domain instead of his own. So that is something which we need to watch out for. uh, uh, that is one type of attack. This shows the actual working of the mail transfers. So there are many mail servers, right? You have Yahoo, Gmail, public mail, private mail, etc. You can configure an email to be your own a public available mail server, and also an organization's mail server. So that is something I've depicted here. Can you move to the next? Yeah, this is the uh, attack which happened. So he tried, because it was loosely configured, the email address at the mail server at the top. He relayed the mail to two other networks where there was another mail server, and they then reached or broadcast their mail to other recipients to whom they did not want this email. So they can use it to relay and farm these emails into other unintended recipients if your mail server is loosely configured. So mail server misconfiguration, it's called the relay misconfiguration. uh, how you can mitigate it? Again, you use authentication and the sender policy framework called the SMTP authentication and SPF. So initially it used to be the case that uh, this protocol was not built with authentication. So every protocol was built like that with in mind. For example, IP does not have authentication. You just make the best effort delivery. You make the effort to deliver the email. So earlier days they didn't think about it when they developed the protocol. Now they have added an authentication feature on top of it. So that is something that is that has happened recently. So you can move to next if there are any questions. Yeah.
So Shravan, this TLS and all the security configuration within the email client, does it help in
Mhm.
any preventing from such attacks?
Yes, yes, because you first verify the identity of the sender, right?
Yep.
Yeah. So that is what I mean by authentication. You can use, so authentication itself means that there has to be a certificate, and a third party has issued that certificate. So that is how it is being prevented.
Got
Hope
it.
that answers your question. Yeah. So the assumption is that you have dealt with TLS and PKI in the previous sections.
So what kind of questions we can expect on these DHCP or SNMPs?
Usually it won't deal with port numbers. It will give a scenario or blend it with another concept like TLS in this case.
Okay.
So it won't be a straightforward question that you can answer. So for example, what is the port number of DHCP? This question won't be asked, guaranteed. It is interesting to know, but this question won't come in the exam. The question will be more from the point of view of how will you prevent, there was an attacker who started his DHCP server and started issuing IP addresses. How will you prevent it? That is that kind of questions will be asked.
And Sean, there could be a
Mhm.
question like SMTP works on I think layer 7, right? So is that question can
No,
be
SMTP is SMTP, correct. You
yeah
are right.
layer 7,
Layer
FTPS
7
2.
protocol. Yeah.
Yeah. So this kind of question comes like this protocol exists in which kind of layer, or otherwise we need to recall all
Mm,
those protocols.
no, generally, as a thumb rule, CISSP is not a test of your memory. It is a test of the application of your concept you have understood.
Okay, okay, great.
So there will be 4 options. You have to eliminate the options. You should not choose, because every option is seeming possible. That is my suggestion.
Okay, thank you.
So I will move to the next. So this is another network protocol we have. It is called network management protocol. So simply put, the network admins wanted a protocol to sit in one place and have a view and configure all the network devices remotely. So you can configure SNMP on those all network devices and collect information that you need, like CPU usage, RAM, network bandwidth usage, so on and so on. So uh, administrators need this information as to we need to put more capacity, need to put more resources, or whatever reason they need to monitor. But the problem is this kind of information is also useful for the attacker or hackers. So the intruders are looking out for this information, and this protocol, like any other protocol, was not built with strong controls or encryption natively. So there was a V1 and V2 of this protocol send it is information in clear text, and V3 is sending encrypted text. Now, regarding how this protocol works, there is something called a message information board, which is configured in all the SNMP agents in all the network devices. There is an SNMP agent and there is an SNMP manager where the network network administrator is sitting. So what happens is these agents are you can poll these agents and get these information from this MIB message information board, or you can configure traps that when there is some information board when there is some information happening or some event happening, you can channel it back to me and I will review it. So both these are possible, but unfortunately this information is valuable for the attackers and it is in exchange in clear text in V1 and V2 and default community strings. So these are all part of communities. So there is a public community and a private community. You connect to communities using a string. It is something like a passkey or a passphrase. Usually the community string for public is public and private is private. So you don't change default passwords. Then uh, uh, what can be done is you the people will use these community strings to connect and eavesdrop on the network. uh, you should change this, of course, and you should try using V3 as a mitigating measure to ensure that all the communication is in encrypted form. So you can move to next. Ah, So another scenario which we have, but which is not currently thought about, which is usually ignored, is the presence of EAP. That is, instead of taking so much trouble, why cannot I just walk into the office with another device? I have one device. I can just carry another device, plug it into the network and just listen what is going on in the network. Would that we should protect against that, right? So what I should, or I will just walk in with another device, use office resources to maybe send emails or browse content, uh, which then I cannot be traced back. I will say this is my personal device. I have done nothing from my work device. So how to restrict this? I should send traffic on the network only through an authorized device. So until that device authenticates and proves itself that it is the legitimate device issued by the organization, it should not be able to communicate with any other devices or send out any other network traffic. So the protocol suite which is used for this is called 802.1x. X is standing for AE, AR, and AF. So this is a suite of protocols. So this is ensuring the layer 2 or the physical device security. So AE is authenticating or issuing a unique key to every device and encrypting the communication flowing out of that device. Then uh, the key the actual encryption is taking place using that. The unique dev IDs are configured using AR, and your just a second, sorry. The AF is actually being used for key agreement. So there are a set of unique keys called session keys which are used by these devices. The to initially get the key agreement protocol is used. AE protocol is used for actual encryption, and AR is managing these devices using a key. So you can use your actual uh, Active Directory, uh, try and challenge and authenticate it using EAP, that is the extended authentication protocol, and then only will you be allowed to send network traffic onto the network. Yeah, questions? Yeah,
Yeah. Sean, this supplicant is applicable for wired or it's for wireless? Because in this
both,
diagram, it's like
both,
wireless. Okay. Okay,
both.
for both.
Yeah, because you can have a situation also, right? So I bring in my device, I try and connect to office Wi-Fi. If it is open, then you can open, but it will take you to usually a captive portal. That captive portal is trying to do this EAP, extended authentication, through means of your Active Directory, and then you are granted access to network and network resources. Any other questions you have here? Basically to prevent unauthorized device from joining your network and eavesdropping.
Okay, so this is one kind of control to protect asset or user from the intruder, you can say.
Yeah, not only
Okay.
from insiders also. Yes.
From inside too. Okay.
Yeah, there can be a scenario that an insider took an unauthorized device and tried to exfiltrate data, try to access data, try to access a file server. Can be the case, right? Also possible with external people. So external people somehow breached the physical boundary, came into your organization, tried to connect using network port. He did not get any access because this security features are enabled. Other points? Yeah. So this is an important topic. Uh, uh, Usually, you have to understand why this concept exists in the first place. Like like I told before, natting is helping us to conserve IP addresses. That is one, and secondly, it is hiding also our public private IP address from public. uh, Usually private IP address, people like to keep it confidential because then um, this is not accessible to other intruders or anything. But if you are behind a NAT, then you are relatively safe. uh, what NAT stands for, network address translation. It translates a public IP address, a private IP address, to a public IP address, because on the public network, when you cross the side to your ISP and on your router, the the private IP address loses its meaning. It is like the extension number I told you. So it does not, you cannot dial it from the public network. So what happens here is it is maintaining a table called a NAT table. So the router maintains a table called a NAT table where you have an association between a private IP address and a public IP address. Now, have you ever wondered? So we spoke of source IP and destination IP. Have you ever wondered? So we know Google's IP address by means of DNS. Uh, how does Google know my IP address to send the message back? Can anybody tell me? Anybody is aware?
Google knows my sender public IP address.
Exactly. And but I am sitting in a private IP address, right? Has anybody done executed this command called ipconfig on your
Yes,
system?
yes.
So what is the IP address you currently see on your system? Can anybody tell me?
192.168.1.10.
So how does this does not have any meaning for Google, no? How are you able to communicate?
So this is
So
given
that is,
by ISP Geo home router, which has a public IP on the other end. And
yes,
when my traffic goes from 190 to 168, it gets translated to something like 42.1.1.0. And Google resends the packet back to 42.1.1.0, which reaches my home
yes.
broadband router, and broadband in turn transfer the data to me on 190 to 168.1.1.
So the operation that is happening there is the NATing. It's clear for everybody. Okay. So you can also see your IP address here. Has somebody tried this? Show my IP. So there you
Yeah,
can
that
see
Public
what
IP.
is your actual IP address. So this IP address that you have and the one you see on ipconfig will be different from each other. So these are public and private IP addresses. So the translation is happening through your router. And IPv6 does not require this because it has a very large address space of 128 bits, 2 to the raised 128 bits. Okay. So what are the different types of NATing? We can move to next slide. Next slide, please. Yeah. Seema, are you there on call? Yeah. Okay. So we have different types of NATing. One is static NATing. So one, it is a one-to-one mapping between the public and the private IP address. So I imagine I have one IP address, one public IP address, and one private IP address. There is a one-to-one mapping between this maintained in the NAT table. Dynamic NATing is where I have a pool of public IP addresses and the pool of public IP addresses. So what I will do is when somebody wants to move out of the network or access the public internet, then what happens is they are assigned immediately an IP address from a available pool, and this is maintained in a NAT table. So this is called dynamic NATing. So the public IP address of sender A and sender B from the same network will be different. In the case of dynamic NATing, could be different. But in static NATing, it is usually the same. Yeah, because there is this one-to-one mapping. But port address translation, that is where there are many private IPs and one public IP. So what happens is, how he is distinguishing, the router is distinguishing between the different uh, computers in the network, is he is opening up a port of each and every IP address, for each and every IP address, and uh, opening another connection with his port. So the same IP address is used, but because of the port number, the connection ID it becomes different. So this is called port address translation. So you can have many private IP addresses mapped to one public address using PAT. Yeah. Any questions here? Clear? Okay, we can move to next. So, okay, routing protocol. So once we have now crossed the router, uh, what happens here is, you have router to router communication. So when two routers need to communicate, they communicate using routing protocols. So within your network, within your different internal networks, the internal routing protocols are used. With the external networks, uh, the BGP routing protocol is used. So these are some of the examples I have given: RIP, OSPF, IGRP, EIGRP, ISIS, VRRP, etc. So RIP is routing information protocol. OSPF is again open shortest path first. Then IGRP is uh, I forgot. Now I need to even, I think, look up the full form. I think it's been a long time. But so these are the internal routing protocols and external routing protocols, usually used for routing between internal and external networks, mainly to enable router to router communication. So that is the only part you need to remember here. You can move to next. So other types of other classifications are also existing for routing protocols. One is static and dynamic routing. Static routing means I will configure and build a topology for the network. For example, I will say that this, to reach this network, this is the path. This is the path. You have to go here. That way, I will put that entry in the routing table. That is called static routing. But this can be cumbersome, tedious, error prone, etc. So we have dynamic routing to build routing tables. So the routers will communicate amongst themselves and learn which is the best way, or which are the possible ways to reach a particular destination. It is similar like Google Maps, right? So you have one route, it will also suggest alternative routes. So it is similar to that. So the routers will exchange information among themselves and build routing tables as per them. But how they do it is another thing. So like I said, there is no authentication, so you can configure authentication to ensure that only genuine routing table entries are put, and genuine routers participate in this conversation. And Here, there are some things known as link state and distance vector protocols. So has somebody done trace route? So
Yes, it will
if you,
show the hop by hop
yes,
devices.
exactly. So if you say trace route google.com, it will tell you how many routers it has to cross to reach that particular destination. That is known as distance. But link state is a situation where you have, it evaluates how much, which is the fastest way to reach the destination, similar to Google Maps. So even though there is short distance, if it has less bandwidth and if it takes more time, then link state protocol will show you which is the best possible way to and the fastest way to reach that particular destination. So these are some of the two uh, classifications we have for routing protocols. We can move to next. Yeah, so routing protocol attacks, like I said, false entries could be put on the routing tables and redirect the traffic to the attacker. So if I am an attacker, I just have to put a false entry and said that this is the route through this destination goes through me. I know the route. It will simply pass on the traffic to you, and you can listen on all the traffic. Now it is remediated through authentication. Like I said, you configure authentication mechanisms like TLS or based or certificate based authenticate mechanisms, and ensure that this particular router is actually genuine. And there is also another attack called wormhole attack. There are two attackers in a network eavesdropping and tunneling this information to gain access to resources. For example, there is a session token or a session ID being issued. Then an attacker is just grabbing that and uh, giving it to another attacker to enable him to access any network resources. So you can enable talk to kind of things that I think it is part of domain 3, time of use, time of check, a kind of controls to mitigate this, and also any you can count how far he is away and which kind of resource he is requesting, and evaluate again. So that is one thing we can do. We can move to next slide. Any questions here? If there are no
So
Can
I
the
think
I have a
yeah,
question.
yeah.
So can the trace route ever be blocked? In the sense, like so there might be some private servers who do not want to give up any the location. So
Correct.
is there some point where we can configure like the public servers or routers to basically
Yeah,
block such
yeah, you
routes? And
can
what's it
simply
called?
drop. Yeah, so you can drop these packets. So a router, so we will see it in the operation of the network devices, but a router is simply a computer with two NIC cards. So it will pick up NIC card. The NIC card will pick up the incoming packet and process it and put it outside the other leg or the other NIC card. So when there is trace routes are essentially following pings. So this is ICMP. So what happens here is you just drop that packet. You don't pick up that packet at all. You don't process it at all. Then that trace route is blocked. It does not proceed further. Does that answer your question?
Yeah.
Yeah. Yeah. Yes, Lokesh. Yeah.
hi, Shravan. So I am just asking this question for exam point of view. Like we don't need to
Mm,
recall the protocol's name. Okay, so which
mm.
kind of questions it can be encounter for us, like static, dynamic, and you told this method, right, for the protocols.
Yeah. So they will combine attacks and say which is best method to prevent, which is best method to detect. They will usually combine this with other concept. Like I said, no
Okay.
talk to,
Mm. Yes.
then authentication, then what kind of attacks can be performed on a router? Can eavesdropping be performed? What is it breach of confidentiality or availability? Then but routers themselves can be unavailable. I can perform a DDoS on a router. So many things. So they will usually combine concept across different chapters and present it to you as one question. You have to apply that entire concept um, fully. Then it is beneficial, because this is like a piece of information that you have, but how you apply it in that scenario, that is useful. Yeah. So 3 hours is the question, and it is adaptive. General suggestion is that you try and do first few questions very carefully, because it is algorithmic, I think, and uh, if you do the first few questions correctly, then your baseline is also good, and you will get questions more in that area of difficulty, and you will have more chances of clearing the exam. Yeah. Yeah, next one. Okay, so quickly we will run through all these devices. Then I think I will hand over session to Usha for to complete the session. Um, so repeaters are also called hubs. Repeaters are also, they are just dumb devices. That means they will just broadcast the packet they receive to every other recipient in the network. The favorite thing for attackers is a hub network or a repeater network, because they get to receive or eavesdrop on all the information free of charge. So repeaters are such kind of devices. Routers are computers. Routers have an OS, a processor, and what they process are packets. So they will so they have two legs or two NIC cards, one in one network, other in the other network, and they will pick up the packet from one interface, see their routing table, what they have put, and try and forward it to the destination. So that is the kind of operations which routers are performing. Then switches are actually again an extension of uh, hubs, but without the broadcast. Okay, here we also have to understand a very important concept. This will be, I think there will be a question in the exam about this topic. It is called collision domain and broadcast domain. Have you heard of these terms? Yes, no? Yeah. So if I broadcast something in the LAN, every recipient will receive it, but my broadcast will not travel beyond my LAN. So that is called broadcast boundary or broadcast domain. Uh, a collision domain is when this broadcast domain or collision domain is the LAN, and when there is a router, the broadcast cannot travel beyond it, beyond the network boundary. So that is called as collision domain and broadcast domain. It is an important concept. uh, just uh, uh, just pay attention on that topic alone, because repeaters and switches are the devices connected to repeaters and switches are in one broadcast domain, but the devices connected to a router are in different broadcast domains. So this network, a broadcast in this network will not travel to the other side. The router will suppress the broadcast. That is a functionality of the router. Then there are gateways. So if you have worked in cloud, you have gateways for everything. You also have gateways for our own computer. So internet gateway, default gateway, many gateways. So if you have to access something, if you go via that, as the name suggests, it is called gateways. Then private branch exchanges are the telephone exchanges which you have for your own personal use. You can put a lease line and also tunnel it for use it for data traffic also. So it is kind of a convergence that they are going on for right now. So your voice and data are using the same physical network and same physical lines. That is one. Firewalls, I like my sir used to define it back then. These are routers with rules. Firewalls are nothing but routers with rules. So there is a firewalls means it also has to have a minimum of two NIC cards. It will pick up a packet, then it has also a routing table, but a routing table, that routing table is as per your security needs. If you want traffic coming into the network and connecting to a particular port, you allow it. If it tries to make a connection to some other port, you disallow it. You say drop that packet. So you are updating all these rules in that table and associations and making it drop the packet, thereby securing what is behind it. Okay, if we go in firewalls, then there are many concepts like demilitarized zone. What is demilitarized zone? So the area between the two firewalls is called a demilitarized zone. For example, but of course your organization needs publicly accessible resources like your website, your mail, and so on. They have to be connected to internet, but the internet is not reliable. There are many attackers trying to exploit your system. So what should you do? You harden this system. For example, if you are operating your web server, you place a firewall in front of the web server and say, I will allow only port 80 connections through this firewall to this particular destination and nothing else. So that hardened host is called a bastion host. And this bastion host is sitting in what is known as a demilitarized zone. And internally, behind this web server, you will also have a firewall where you can connect from internally, but from the firewall, you cannot connect inwards. So that kind of rules you place inside these firewall, and firewalls need to be configured. You just you can have also any to any rule, but it is as good as leaving the door of your car open and the keys inside it. It won't be there. So yeah, a firewall has to be configured. Many different kinds of firewalls are present. You have proxy based firewalls, you have stateful firewalls. uh, why do you think phishing attacks are happening? Can anyone give a reason? Firewalls are there, no?
So there is
Phishing
no
is
mail
public
security.
based.
Yeah,
There is no anti-malware or anti-phishing components in the firewall. They both.
true, but the firewall, why it's my question is, why is firewall not preventing this?
Phishing is publicly actually. Anyone can send mail to any other person.
No, but firewall is preventing the public people from accessing internal resources, no? Because of the concept I just said, the statefulness. Because you initiated the connection outside, and when you initiated the connection outside, it keeps track of the state that, oh, this person has initiated something, and when this package comes back, I should be let in. If you go in a club or something, when you authenticate, he gives you a stamp on the hand, right? So when you go back and come back in, you are allowed inside because I have already authenticated. So the stateful firewall keeps track of the state of the connection. If it is my connection which I have initiated by clicking that link, then it allows it in, right? You are able to get this concept?
But next generation firewall do have the
Yeah,
ability
yeah.
to do that, right?
I will come. I will come there. I will come there. Yeah.
Okay.
So you, yeah. So you first, from the rudimentary you build up. So you had initially one firewall, two NIC cards, apply some rules. Okay, fine. But what happens then if you? But what happens if you initiate the connection? Then I should use something like UTM or next gen firewalls or something like that. But yes, so stateful firewalls are keeping track of the state of the connection. So to enable access to outside world to internal users, that is one type. Then you have UTMs and next generation firewalls, which are integrating a lot of capabilities like anti malware, then signature detection or something like that. Uh, so another thing, if there are firewalls, why do we need IDS IPS? Can anybody go for it?
To find out the malicious thing, like signature-based attack on an
My packet
anomaly-based
will not
attack.
reach me now. I have put a rule in my firewall that all these IP addresses are blocked. I know all the bad domains. I have blocked them on my firewall. Drop any
But
packet
we
which
cannot prevent
comes with
zero-day attacks. We cannot stop. So maybe
exactly. So what happens is if there is a 0 day and everybody is aware of 0 day attacks here, I would assume. So if there is a 0 day, then there is a signature that is coming. There is no patch for it yet. So you update this signature in your IDS and it looks for these suspicious behaviors and catch hold of him. It is like having a wanted poster everywhere. I don't know this person is running anywhere, but he looks like this, he talks like this. If he comes like this, be alert. That poster you see everywhere, no? Similar to that. So that is one function. So you can integrate many of these things in a firewall. With cloud, it has become even more complicated, like CNAP, CSPM, and stuff. But the basic funda is this. Yeah. And okay, main difference, everybody is aware of proxy, right? So proxy is also something in between you and the internet. Firewall is also something like that. So what is the difference? Can
Proxy
anybody
just
take shot?
proxy just replaces your IP address to the internet, while firewall is more of a prevention mechanism.
NAT is also doing that. We saw that earlier. This is where the conceptual, the OSI model and the layers, you have to go back again. So what layer are these devices operating at? So repeaters and switches are layer 2 devices. Routers, firewalls are layer 3 devices. And you can operate at below layers also. So you can operate at above layers also. So you can have a layer 7 firewall also. So proxy is operating at layer 7. That means when you are initiating a connection, you connect first to the proxy. The proxy will say, okay, this is, I have configured some rules on the proxy that these are the allowed internet sites I am allowed to browse. And then the proxy then initiates a connection on your behalf to the actual site, opens a connection, then the request comes and then it channels back the connection to you. So that is how this thing is working. It is working at different layers. This will also be testable. So which device, which layer, what if that does this does this, what is the best to implement? This kind of questions will come. It will seem like everything is there is one computer here, one computer, one server there, and something in between. But what that thing is doing and how it is operating, that will be testable. So you can refer. I think Sean Harris is a very good resource, very lucidly explained. OG is OG is of course the recommended book, but I studied using Sean Harris, my personal experience. So refer different types of material. Do practice questions like these. So that is very helpful. UTM is Unified Threat Management. It integrates many capabilities like malware detection and stuff. Uh, okay, CDN and SDN. So these are not devices, but these are concepts. You can configure things to deliver in a particular geography or something. For example, if you are browsing Facebook, it is best to deliver it from Indian servers rather than connecting to actual US servers. Or if you are streaming, say the final tomorrow, then your content is delivered from the most proximal servers. So if you know of a company called Akamai, actually they do this content delivery networks. So and of course, not
so
recommending anything, but
CDN,
examples.
SDN is the cloud services, or it is on-prem also?
You can configure, you can design it to be on-prem.
Okay.
So some content has to be high performance for something, then you can configure it. You can, there are many options, like you can have quality of service. There was a field in the IP packet, if you go back you can see, you can prioritize some type of traffic. All that is possible. So that is one. Software defined networking is actually the concept which is in use after cloud. It has become more prevalent. You do or configure networks as software, as pieces of code. It is more prevalent in the IAC world now, infrastructure as code and so on. So that is one concept. Honeypots. Yeah. So you
But CDN,
anybody? Hmm?
CDN and SDN are different concepts, right? It's not one and the same.
No, they are not one and the same. This is for content delivery. This is software defined networking. Is your your software is trying to assess the network traffic and the patterns, and trying to configure networks according to that.
SD-WAN and SD-LAN types.
Yeah. Then honeypot is like you make, you try to detect the uh, have you heard of TTPs? It is popular with the MITRE attack framework. So these tactics, techniques, procedures are used. How these techniques, procedures are used, that is being developed, that is being assessed using the honeypots. So
So
you
you
place,
create a trap
well, yeah,
and
you
put.
create a vulnerable asset and make it very attractive for an attacker to actually compromise it. But using that, you try and see what are the techniques he uses, and what is this modus operandi to basically compromise a system, and try and patch your systems accordingly. So that is called as honeypot. So these are the kind
Usually,
of. Hmm.
usually honeypot and sandboxing are mixed together, right? You create a trap,
No.
get these or not.
Yeah, correct. So honeypot is again not having direct connection to your network, because somebody is trying to compromise it. So from that, you should not hop on to other assets on your network. But you have this in a sandbox and try and compromise it, so that the attacks are contained in the sandbox. Yeah, you're right. Okay, so we can move to the next one. And
Just a general question about honeypot.
Mhm.
Means which kind of organization made it like? Because in general, organization does not create honeypots and all that. So who creates this?
Usually the organization which are into security research, which are developing anti-malware, which are looking out for uh, uh, to get ideas, developing ideas or developing signatures to attacks, they will be interested to develop honeypots. Uh, now it is be now you have a requirement called DORA in the EU. We are now doing something called threat-led penetration testing. So you are not just getting a list of IP address and just scanning and giving a report in the final. So that is not the objective. So you assess your threats, you try and determine which are your most valuable assets, try and compromise them, and then try and see if all your sensors and alerts are working to contain that attack and detect that attack and prevent that attack. So that is the objective of this thing. Okay, so hopefully I have covered all the topics that I could. Would now like to call on Usha to present the remainder of the slides.
Yeah, just a minute. Huh?
saw Busha leaving the meeting. She got disconnected or something.
Okay.
Just hold on. Let the team get her. In meanwhile, maybe if the team have any question, they can continue.
Yeah, please.
Nainika, can you please discuss? Check with Usha whether she can come back.
Yes, ma'am. She said she will join.
Okay.
One question is Sean. Actually, Sean, nowadays we are using WAF and all, right? A lot of for the application securities. So do we CSP has means like the contained and the questions related to the WAF or any same kind of security technology which we can choose either these something like that.
Yes. So mainly it will be like when they ask question about devices or something, they will ask about which layer is this device operating. Because now WAF, if we say it is operating on layer 7, it is trying to contain the attacks at the web application layer. It is intercepting the queries coming out of the web application and trying to filter them, and not trying to reach the database and do some compromise. So yes, you can have a firewall operating at this layer, and there will be questions to that effect.
I think Usha has joined the call. Hey, Usha.
Okay, handing over to Usha for concluding the presentation. Cheers. Thanks.
Thank you, Shravan. Am I audible?
Yes, Usha, you're audible.
Okay. Let me share my screen. Is my screen visible now?
Yeah, it's showing. Just keep it in presentation mode. Bottom right corner, there's one present here near the Zoom.
Okay. Just 1 minute. Huh?
No problem. Zoom options are there, no? Plus, minus. Next to that, before that.
Is it fine now?
No, I think you have to select the presentation mode. Bottom right corner near the Zoom, presentation mode is on. No? The next one. Next one. I think this is fine.
This is fine?
Yeah.
Is this okay? Yes.
Yes, this is fine.
Okay. So I'll be covering only the wireless security, mostly about the wireless configuration and what is required from the wireless point of view. That is what I'll be covering. In CISSP, when it comes to wireless security, you just have to know what are the wireless attacks that can happen, and mostly how you secure your wireless. And in this, you'll have to understand what are the authentication protocol, how your wireless is getting authenticated, and how the encryption is happening at the wireless level so that your wireless network is secure. Now, if you if you understand exactly how wireless work, there are three major protocols: WEP, WPA, and WPA2. Now we are getting WPA3 as well. So you have to understand in this what are the key features that are there in WEP, WPA, and WPA2. WEP is nothing but a wireless equivalent privacy. So in this, they are using so what happens is when a user or a device, whenever he's trying to access the network, that is your access point, you share the password, right? Only once you share the password, it is authenticated and then you can start the communication. So initially when wireless technology was invented, we were using weak shared password. Now you have, I'm sure that most of you have read cryptography. So this cryptography is carried over here as well. Cryptography is used in the entire security, right? So what you don't have to in-depth understand how the encryption is happening, how the protocol is functioning, but you need to understand which protocol and which encryption key is being used in which wireless protocol. Now, when I'm talking about WEP, it is using a weak shared key. Okay, it is using a shared key. Mind you, it's not using a public private key or a certificate. And that is one of the major drawbacks why we have come out of WEP. It was using a 24-bit initialization. When I say initialization vector, it is IV with RC4 in encryption. What is initialization vector? Initialization vector is like a random numbers will be selected. And then when you share your password using this initialization vector, it is added to it, and then the password is being encrypted with RC4. So once it is done, then the entire data is encrypted with RC4, and then you establish, then the data is being transferred. But you know that in 24-bit, and it is also a shared key, plus it is using an initialization vector. So initialization is vector is after every 5,000 or maybe above 5,000 IVs. That is, when I say IV, it is a random number. Okay. After that, it gets repeated. So once it is repeated, it is very easy for an attacker to uh, to actually find out what exactly is the data, to decrypt it, and then he can perform his attack. That was the main reason why WEP was outdated. And then we came to WPA2 and WPA3. So in the exam, if they ask you what was the main reason, it is just the initialization vector, which was weak, and they were also using weak shared key. Next, let us understand what happened in WPA and WPA2. WPA, you started using TKIP, which is again a protocol which is used for communication, to establish the communication and to encrypt the data. And WAP2 started using AES encryption with CCMB. CCMB is again a protocol. With that protocol, it started using encrypting the data with AES. That is the reason it became much stronger. Now, AES, in symmetric key, the strongest, even today, currently we are using AES in our TLS encryption and all, or in a database. When we talk about encryption, AES is the most secure. So WPA2 started using AES, whereas this TKIP and CCMB, these are transmission protocols. Okay, it will transmit using that protocol, but it will encrypt with AES. That is the reason AES became more strong. And if you see the key management here in WPA, it uses shared key and it uses dynamic key generation. But in WPA, it uses stronger key, which is nothing but AES, key management with CCMP protocol. And WPA2, it requires newer hardware. Like supposing users are using old routers, then they have to upgrade their devices to the newer version. Only then WPA2 they can work on WPA2. Whereas WPA, you can still upgrade from WEP to WPA, but you cannot directly go from WEP to WPA2. If you want to go from WEP to WPA2, then you have to buy new hardware. So this is one of the drawbacks why people ended up going to WEP. Then later they moved to WPA2. And when it comes to supporting enterprise with Radius. I'll tell you what Radius does and how the encryption happens, how the communication happens. But for now, you understand that WPA2 is used at an enterprise level. Like big organization, they have to use WPA2 for stronger encryption, whereas WPA can still be used with a small Radius server. What is Radius server? I would be covering up that in the coming slides. Now understand how WPA and WPA2 works. Okay. Now, if a sender is sending a message, so this message is encrypted with your encryption key. Here it is, if you're using WPA2, it is AE2, AES. So after it is encrypted, it has been encrypted, it comes in a cybertext, okay? And then it goes to your wireless access point. And on the, now this wireless access point, it also has a session key which is shared between these two devices when the authentication happens, right? From this sender access point to the receiver's access point, there will be a shared key, session key that will be shared on both the devices for handshake. Once that has happened, then it will, since it is using the same key, it will decrypt it. And then once the decryption has happened, it will receive the, then the end user will receive the data, whatever whatever the sender has sent. The entire communication is encrypted, if you see. So if an attacker is trying to find out what is there, what data is getting transferred, he will not be able to decrypt it, because it is done through the session key which are shared between the devices for a handshake. You understand, when we talked about in cryptography chapter, we talked about how cryptography works, what is public key, what is private key. The same that is, now this is the place where you apply those technologies. Now your TLS certificate, your SSL certificate, all these certificates, they use these and cryptography technology to make sure your communication is secure. Now, let us do a quick question here. As part of network security review, the security manager needs to understand the encryption protocol used by various security standards. For WPA, which encryption protocol is used to enhance the security? Mind you, it is WPA. So here we are talking about protocols. We are not talking about the encryption method. You're talking about protocols. So WPA uses TKIP protocol, whereas WPA2 uses CCMP. So the answer here would be C. Okay. If it is WPA2, then it would have been counter mode with cipher blocking changing message authentication code protocol, that is CCMP. Now, in our organization, right, like huge organization or at an enterprise level, we have a different port-based network security. What is port-based network security is, whenever you try, now if even at home, like, you just enter your password and your access point will allow, your router will allow you to access. But at a very big enterprise level, everyone can't use the same. I mean, you can use username password, but then imagine how insecure the network would be. So Cisco and many other vendors have come up with this port-based network security. What happens in this is, there is something called an authentication server, and then there is a authenticator. Now, if any device, application, user, anyone who's connected to the network will send a request to your wireless access control or your authentication or your access point. Okay. Now, this access point has to verify whether this user is authorized to access whatever he wants to access. Okay. At that point of time, access point will send the credentials to the Radius server. Now, Radius, it can be a Radius server, it can be TechX Plus, depending on the organization. Now, authentication server will have a database. It will store the username and password. It will check whether this user is authorized to Okay, this user, he will, first of all, it will try to authenticate. But now at an enterprise level, we also have policies where if a user is trying to access another department or another team's information, he will not be able to access it. So you can even configure those policies at authentication server level, at the radius level. So this is complete, this whole communication we are communicating in terms of this protocol called 802.1x protocol. This is not only securing, this is actually securing only the port communication it is securing, not the transmission. Okay, it will just authenticate, and then if it is allowed, then the communication will happen. Any questions here? Okay. Uh, so it prevents unauthorized, even if any unauthorized user or a device is trying to access, it will prevent it because it will check its database, whether it has username or password, and uses individual credential instead of shared Wi-Fi password. Even in your offices, you might have seen you enter your username and password and it authenticates, right? Because you have your unique NT login, enterprise ID. So this radius is actually connected with your AD in turn, and then it will have the communication set up in that way. Then it will try to authenticate. And sometimes it not only authenticates you using username and password, if your infrastructure is more secure and if they have, depends on what kind of information they're trying to access. Some organizations also have digital certificates for authentication as well, smart cards or passwords or whatever they want to set up, they can set up using this 802.1x protocol. And it can be worked on WPA2, WPA3, and corporate LANs. Now, WPA3 is again one of even more advanced version of WPA2. It uses SASE protocol. Again, one more question here. An enterprise organization is upgrading its wireless network to enhance security and ensure compliance with industry standards. Okay. To the security manager needs to choose a wireless security protocol that allows the organization to leverage its existing authentication, authorization, and accounting service, such as Radius and TechX. For user authentication, this will help to maintain a centralized authentication process while providing robust wireless security. See, as I said, WEP, WPA, these are all cannot be used at a huge enterprise level. And if you see, this question is more talking about accountability, authorization, and it is talking about radius, TechAx. It's not a home network. You can understand very clearly from here. And it's all saying that they need a centralized authentication process. Open system authentication, it cannot be because it needs a centralized authentication process. So what could be the answer here? It will be 802.1ix. Next. So a whole CISSP, right? In network security, you will be learning lot of protocols. You will learn authentication protocols. You will learn about dial-up protocols. You will learn about transmission protocols. Now, you have to segregate like which protocol does what. Okay, when I say routing protocols, it will be your TCP, all those kind of SNMP. These are like they're transferring the data, right? So they will become routing protocol. Now, if I'm talking about protocols like authentication protocol, is there a question?
Yes, Moshe, ma'am. I have a question
Yes.
related to the previous slide.
Yes.
Okay. Here you have mentioned, I think, no pre-shared key.
Yes.
So I want to know why
This one?
no means, yeah. No, next one, yeah. This one. So it just mentioned no pre-shared key. What it means?
No pre-shared key is they are using their own passwords. There is no like a shared key. If you remember cryptography, there is a shared key, right? Asymmetric, symmetric encryption, where both user and the receiver both have the same password, and that key is not shared with anyone else. It is the symmetric key. So here they're not using any shared keys. They're just using individual credentials. That is like your how you log into your router, just your username password, simple username password. That's it. Okay. Okay. Yeah. Now we're talking about authentication protocol. What are these authentication protocol and in which stage they are used? Okay. When we talked about this, right, 802.1x port-based authentication protocol, now this protocol works at this layer. Okay, you should know which protocol is working at which layer and where the communication is happening. When it is trying to access the data at that layer, this protocols will be used. Plain text username and password. Okay, when it is trying to authenticate to the radius server, when your access point is trying to authenticate to the radius server at that point of time, if the protocol is PAP, then PAP uses, these are PAP, CHAP, LEAP, EAP, PAP, EAP-TTLS and TLS. These are all the authentication protocol, and different authentication protocol has, like, it started off with PAP and then it has evolved, and today we are using EAP-TLS, which is the most secure authentication protocol. Initially, when PAP came, it was using plain text username and password. Then the next was the CHAP. CHAP is like a nonce. Nonce is nothing but a random number will be generated between the requester and the authentication server. And then they will exchange, like supposing it will say, okay, can you give number two? Then even this receiver has to enter number two. That challenge exchange response happens, and then the authentication happens in CHAP, which is still not very secure. Next came LEAP. LEAP was again a password based authentication, but it was Cisco proprietary, so it was not very widely used. After that, we came with EAP. EAP is a framework which supports multiple authentication methods. It supports encryption methods, it supports certificate methods, and password protection method also it supports. That's how, after PAP, EAP, PAP, it has evolved with, it has this password based authentication. And what happens is, when you're using PAP authentication at that point of time, like client and server, like, this is the client here and this is the server. So the client, every client should have every server should have the certificate, and then it will authenticate using that certificate. After that, it will proceed with the communication once that is done. So only server side authentication was done, but that authentication was based on password. Then comes a EAP TTLS. Here also the only server side authentication was done, but the communication, the encryption method that they used was not very secure when compared to EAP TLS. EAP TLS, what happened here is, client and server side, both the side, the authentication had to be performed. Only then the communication can be established. So these are the different authentication protocol that are more testable.
So does it mean like EPLS required both sides certificate too?
Which one?
Client EPLS. So it require both sides certificate, client and server certificate.
EAP TTLS or
EPLS? EPLS.
TLS, yes. Client and server side, both side certification.
Okay, so it will mutually authenticate. Then it will.
Yes,
okay.
It will mutually authenticate. Correct.
Okay.
See, PAP, it had, like laws of lot of vulnerabilities. It has, like, people can do man in the middle attack in it. And CHAP, if you say, it was since it is using challenge based, maybe it was prone to dictionary attacks, like weak. It was also have some passwords issue. Because of that, against it was weak against brute force attack as well. Chap. And the best part, the best is the TLS for now, because it requires certificate management from both. It is little cumbersome because it requires certificate management from both ends. Next is, we'll do one quick question here. An organization is currently using EAP Leap for wireless authentication, but is concerned about its potential vulnerabilities. The organization is considering more secure alternatives. Which of the following authentication method provides the strongest security? So that would be EAP TLS. Yeah. So this is about the wireless communication, where you have to know about WEP, WPA2, and authentication protocols, as well as the dial-up protocols that you have. If you understand the differences, which is to be used where, that should help you. Any questions related to this?
Just a use case for each kind of protocol where we are using it, like TLS you told, but MD5 and all, any real use case.
EAP, PEAP?
EAP MD5, yeah, EAP MD5, PEAP. Any use cases
See,
like
MD5, you know what is MD5? It is for, MD5 is hashing protocol, if you remember. In cryptography 5, you might have heard about MD5, right? It is,
Message digest, I think. MD5.
yes,
yes, it's for integrity means hashing is.
right. So it only verifies the authentication, and it since it's a basic network authentication, it is used with legacy VPNs and PPP authentication, but it has to be supported with something else. Like you can use a challenge handshake with it, or you have to use any like hashing with the password. Only then it is okay, but it is morely not currently used in the network. We always go with EAP TLS. It is not a very secure way of authentication, because the client sends, what happens here is the client sends the username to the authentication server. Then the server will just send any random number to the client, and the client will hash the password with the challenge using the MD5. Okay. And if this random number is being detected by the attacker, then your network is insecure. That's how it works. Whereas TLS has the certificate, right? Because of the certification method that it is using to authenticate, it is more secure.
Okay, so EAP TLS can fit in all kind of use cases, I believe.
Yes. IPsec, we can
Yes.
use it. L2TP IPsec you can use. 8021 you can use. Actually, in this modern network, right, we are not using EAP MD5 because they are more vulnerable to all these brute force attacks. There is no mutual authentication. So I have not seen anywhere using EAP MD5. It is outdated mostly.
Okay.
So
Yes,
done, Usha?
Yes, Satya. Yes, Seema, I'm done.
Yeah, thank you so much, Usha, for giving your topic. I will just share one. I wanted to share one more minute with you all. Just a minute. It's on the our upcoming events on. We have a monthly event on 22nd March. If you want, you can register over here. And we have the upcoming webinars also, which is on domain 5 and 6 and 7 and 8. You can register here. You need to visit our websites, or you can even do from the LinkedIn page. And we have annual event coming up on in September. You can do pre-registration for the annual event also. You can find the ways here. If you have any difficulties in registration or something, this is a event page where you can go for pre-release offer registrations. If you have any difficulties, you can reach out to me or any of our team member. You can find them on LinkedIn. Our LinkedIn post, you will find all our members there.
Seema, I guess they are not seeing your screen.
Page, is it? Oh, okay,
They're still
okay.
seeing
Just a minute.
Usha's presentation. Yeah.
Okay, sure.
But
now.
while you pick it up, guys, thank you very much for being there. Shravan and Usha, excellent job you have done today. Hope the team learned well. We actually run on claps, guys. So do clap us on our LinkedIn pages or other places, because this team does a lot of effort to prepare. While they do their job, they are actually dedicating their weekends to do this. So do appreciate them publicly. So that is their motivation. Nothing else they are getting except for this thank yous. That's what motivated them to do more sessions like this. So appreciate if you do that. Second, I think I just want to add up to what Seema is saying. So you are seeing there is the annual summit in purple.
Yeah.
So we do have pre-release offer, limited tickets only for 100, and the price is completely low. I think lower than anything else, but it is only limited number of tickets. So if you are interested, go ahead. We are expecting anywhere between 100 or more CXOs and 600 plus uh, audience there. All are professionals. So you can see what else is coming up on our main page. For more information, go to our Summit 2025 and understand what we are bringing onto the table. Okay, Seema, back to you.
Yeah, so we have this monthly event going, upcoming monthly event on 22nd March, which is at Netscope. You can register for this as well. And we have podcast going on where you can, this is a free podcast, I believe, where you can go and take insights of what Gen AI is doing in this current scenarios. You can have the insights from Satyavati and Prem Kumar also, and many other leaders are participating in this. This one, this is the webinars which we are conducting. We, other than the CISSP, we will be doing other webinars also on the other topics. So we are, you can go and register here if you're interested in the upcoming topics, which is on Zero Trust and IAM Essentials. And the next one is on the
Not announced yet. Yeah, it's not
security
announced yet,
operations.
but it will be launching soon. Yeah.
Yeah, security operations, and then software development lifecycle. Those topics, those domains will be popping up. You can register here. And any queries you have, or any interest you have in uh, presenting, or you need a opportunity to talk around on those topics, you can reach out to me, or you can reach out to any of our team members. We'll be happy to have you, provided it meets our requirements. Any doubts, guys?
Hi. Just a small thing from my side. Before we wrap up, I thought
You
one.
want to take the opportunity? Yeah, sure.
No. I think I missed one point in the thing. It is about VLANs. I think while discussing switches, I should have discussed that. I
You
think
can,
that was missed.
yeah, you
Yeah.
can discuss if you want.
Yeah, so very briefly, I will tell that. So VLANs are implemented in switches. They are implemented in layer 2. They are also like any other partitioning any other network with the router. They are also suppressing the broadcasts. So broadcast will not cross a VLAN. So that is something which is very testable actually. So they will ask which layer is VLAN implemented, what is the difference between VLAN and network partition, something like this. So even though they are all on same LAN, you can still be on different LAN. So it is implemented at layer 2, whereas router is doing this at layer 3. So go through your the OG or the study material what you have. In case you are not able to get anything, you can reach out to me.
Thanks, Shravan. Thanks for the note. And anyone, I mean, if you want, you can follow us on LinkedIn on the CSA Bangalore chapter webpage. You'll find the, you can visit there and you can follow on LinkedIn. Usha Kumari is also available on LinkedIn and Shravan also. You can follow them. And if you have any queries, you can reach out to them. They'll be happy to help you. And thanks for joining the session, Shravan and Usha. Thanks for it.
Just a quick question. Will you be giving out certificates for the participating?
Yes, we can. We'll definitely send it out. And Geetanjali would be sharing. I mean, from our support email address, you will be getting a feedback form. Do fill it up so that we have a what do you call areas of improvements, and if there are any changes you need or any pattern or model to be changed in the presentation or something, we can definitely take it into consideration. Also, positive feedback also would be needed so that it's an encouragement to the to the members as well as to the chapter also.
Yeah. So
Yeah.
just one topic, guys. So this LMS portal is new. So this is your first batch. So we want you to explore the SIBE LMS portal, where we have huge lot of questions we have added, which are actually highly tricky and complex. Practicing them will help. So we've added the course material. This recording will be available, and the presentations the speakers used will be available, as well as the mock tests. All of them are available to you. Because this is our first batch, we want to make sure that you are getting all the material available at time, and also we are looking for feedback, as Seema rightly mentioned, just to give us information and also start talking on the community. That's how you collaborate. Use the community well. It's
Yeah,
a
thanks, everyone.
proper LMS portal, guys. That's something we specially purchase for these methods. Okay.
One question, ma'am. Seema
Yeah.
ma'am. Actually, I missed the first session, that is risk assessment domain. So,
Okay.
how is there any possibility to cover it up by?
Yeah, it's available
Email?
as a on demand now. So once the session
Okay.
is over, so this will be available as on demand. If you haven't purchased already, you can just go ahead and take it, and then you can access module 1 to whatever the module you missed. It applies to future modules as well. If you are not able to access it physically or virtually on that day, you can take a recorded session later.
Okay.
Okay. Thank you all. Anything else, Seema? Otherwise, we're good, right?
Otherwise, good. Yeah. Thank
Yeah.
you so
Thank
much.
you, everyone.
Thank you, everyone.
Thank you all. Bye-bye.
Thank you.
Thank you, Shravan. Thank you.